So we left off talking about the Richter scale. Now we're going to talk about the waves going through the earth. So here is the earthquake. The waves are sent out. P waves and actually S waves. This diagram is showing us P waves, but this is P waves and S waves. Now, P waves and S waves would be all the way here, all the way here. P waves will go through and end up here. You will not get any S waves. And the reason for that is the outer core is liquid. S waves do not go through liquids. So only P waves would arrive here. But now, because of this deflection here and here, we get what we call shadow zones, where no waves will arrive. And that's because of the difference in density between the core and the mantle. So, get a shadow zone here, get a shadow zone here. Only P waves can arrive here, and you would have P and S on this side and this side. All right, where do earthquakes occur and how often? You guys just did a lab on this. All right, you were supposed to plot where the earthquakes and the volcanoes are, and 80% of all the earthquakes occur in the circum-Pacific belt. The Ring of Fire. The Ring of Fire. Good song. Johnny Cash. So right here, look at it. Ring of Fire. Where earthquakes are, volcanoes are. 80% of them. Ring of Fire. Most of these result from a convergent margin activity. 15% occur in the Mediterranean Asiatic belt. 5% yada, 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 yada. All right, there's more than 150,000 quakes strong enough to be felt that are recorded every year. So earthquakes are happening all the time along the plate boundaries. All right, economics and social impacts. So this is kind of crazy. Depending on where you are, is whether or not the earthquakes are going to have more or less of an effect on you. Not because of the strength of them, but because of the socio-economic impact. For example, California, a lot of money. Build the buildings correctly. They actually don't make them earthquake proof, but earthquake resistant. They are able to move with the ground. A lot of the poorer countries, when they get hit, it's devastating. Wealthier countries, they are able to build much better structures and people survive more. YouTube video, copy that, watch it. Great video. Now, this is the fun stuff. Finding the epicenter. We want to know where the earthquake took place. Okay, so that is where our P and S wave come in. So, as we talked about before, focus on the ground along the fault line. Epicenter is on the surface. That's what we are looking for, the epicenter. Now, take notice here. You have a P wave arrival. So here's a seismogram. The P wave arrives at a certain time. After that, the S wave arrives because it's going slower. P wave is faster, it arrives first. S wave is slower, it arrives second. Now, because of this difference, we can figure out how far away the epicenter was from this seismograph station. So if you look here, this looks like it was 30220. Now let's talk about this for a second. We're going to be doing time again. 302 to 303, 30220, 30240, 30260, 60 seconds in a minute, which makes it 303. So 30220, and this looks like it is 30620. You're going to subtract the time, and I'll show you that in the next one. Notice this station has a different arrival time for P and S wave because it's a different distance. Same thing here. Different arrival time for the P and the S wave, and that's because it is a different distance. So what we do, oh, look, perfect, up 30220, 30630. We subtract